TA algorithm. So we also TA the stuff that no one else is doing.
All right, so you have an assignment due tomorrow. And then one more coming out for next week. Are there any questions or problems about anything before we start? Yeah?
How many test cases would you want us to add to be thorough?
Well, let's talk about that. How many test cases do you need to be thorough in testing something? What should your goal be? You got any ideas? Yeah?
I'd say one to test every different kind of odd case you get.
Okay, so we said at least one test for every odd case as a starter. So what that means is, in the specification, it will say if this is the situation, throw an exception. If this is the situation, throw a different exception. If this is the situation, return 0. Otherwise, do the main thing. So if there are all those cases in the specification, there should be that many test cases. Make sure that exceptions are thrown when they're supposed to be. And so by test case, I mean you have multiple test methods testing the same thing. And then, for testing sort of the main behavior of the method, you need to have, you've seen what I do. I try to throw in, I give you 4 or so to start with and add 4 more for grading, but you don't need to do 8 different test cases on the main situation, but several. Okay? Questions, yeah?
Just had one of the specifications in part 2 specified that when an invalid file was selected, the program would behave in a certain way. I just what's a good way to test opening an invalid file?
Okay, he's asking how do you know when there's trouble opening a file. You just have to open it. You create a scanner to read from it. And if it's not readable, it'll throw an I/O exception. So you find out by opening it. Yeah?
So if you just run the program PS5 library, it should print out the result and generate text, right?
If I forget what's in my main method, but yeah.
Yeah, it's the thing. So if you implemented everything, it should print out.
Correct. If you've implemented your methods correctly, then when you run my main method that calls my generate text method, it ought to generate some text. Yes?
One of the methods is supposed to do something that checks for a pattern and then returns the character after the pattern. What if a pattern occurs twice? Like say you're testing a string for the pattern AB and you get AB, ABC. Do you return the next character regardless, or do you check?
Okay, there is no method that looks for a pattern and returns the character after it. There's a method that looks for all occurrences of the pattern, finds all the characters that occur after the pattern, and returns one at random. And then there's one which does that and returns a list of all the characters. It's not like you never look for the pattern once and return the character after it. Okay? So if your string is A, B, C, A, B, C, A, B, B, then the method that's supposed to, if A, B is the pattern, what should the method that returns a list of all characters that follow the pattern return? It should return C, C, B. Because there's a C after the pattern, there's a C after the pattern, there's a B after the pattern.
I remember that now. But
What about the method that's supposed to pick one at random and return it? Right, it should return C 2/3 of the time and B 1/3 of the time. Just by picking a random index from 0 to 2 and indexing into there first.
yeah, I'm just wondering. Say if you have a string, the same example, you have AB, ABC. What do you do then? Is it just supposed to return the A, or do you skip it?
Say A, B, C,
Yeah,
and the pattern is
AB.
AB. Well, there's an A that comes after the pattern. There's a C that comes after the pattern. That's 2. So
Okay.
pick one. Now, just as a hint, your method that returns a character at random is going to be a lot simpler if you make use of the method that returns a list of characters. You find yourself writing the same code twice, you're doing something wrong. In general, if you find yourself copying and pasting code, that ought to be a sign that you need to be making a method and calling it multiple places instead of copying the code around. Yeah.
So isn't it that it's supposed to not return the last index one, so wouldn't it just be A in that case?
No. The thing about a tail occurrence is this.
Okay.
If the pattern occurs at the very end, there is no character after it. So we don't count that pattern. But in this case, AB is not the last thing in the string, C is. Yes?
If the string has spaces, and it's the tail occurrence of a word that's within the string, it'd be okay with the space.
Okay, she's asking, well, I'll paraphrase what she asked. What if the string has spaces in it? That's a character. You know, we're using this stuff to generate random text, and the random text is going to have spaces in it, or it's not going to look much like a book. So, you know, spaces, new lines, punctuation, not just letters, any character. Yes?
Do you want us to be commenting on code for all the things that are going on in our lives?
Okay, she said, do I want comments in the code? Well, certainly you need a Java.comment for every method you write. Okay? If you are writing huge amounts of code in a single method, then you need to be putting in non-Java.comments, just // explaining what each block of code does, just to make it more readable. You might consider, rather than writing a huge long main to implement the generate method, the generate class, breaking those chunks off into separate methods. For example, you have to interact with the user to obtain a positive pattern length. And that may involve prompting the user multiple times as the user enters bad things. Then you have to interact with the user to obtain, I shouldn't have said positive, I should have said non-negative. Interact with the user to obtain a non-negative length. So if you put that all in your main method, you're going to have a chunk of code here and a chunk of code here that's virtually identical. So what should you do? You take this chunk of code, you make it into a method, get non-negative integer from user or something, and call it twice. Now what kind of parameter would that method need? You're going to use the same method to twice prompt the user for input. What's that? No, it's reading from, it's not using a scanner, yeah?
A string prompt.
Yeah, the prompt to actually be displayed, right? You pass in the prompt to use, and it can prompt the user, return an int. You call it again. That way your main method is just 2 consecutive method calls to get pattern length and text length. And then you got a method over there that you're using twice. That's programming. Then you make sure you put JavaDoc on the method. Yeah.
When I'm first making the method, I create a JavaDoc, but what I do is I just copy your instructions from the canvas into there.
Mm-hmm.
Is that okay, or would you prefer in our own words?
Okay. So that's an interesting question. I talked to Stefan about that, and I said, you know, the way I write, sort of the tenses, the verb tenses, and that I use to describe something to you in an assignment is different from the tenses I would use in a comment. And so copying my text into there isn't the way I would do it.
However,
Stefan said that's way too subtle, because he finds students that are, the way they paraphrase it is, where I say, you know, if the number's negative, throw this exception. If the number is 0, throw that exception. And the number is positive, return the square root.
else. You use else.
You know, I say if, else, else. Then he says, then the students are paraphrasing it as return the square root, leaving out all that stuff. So it's a lot better to copy my language into the comment than to leave out essential details. The comment needs to be as precise as the code. Okay? They're both describing the same thing. They need to be equally precise. One's written in English, and it's describing the overall computation. It's not describing the steps, just what's returned or thrown. And the code is computing that. So both have to be precise. Yep.
How do you differentiate in your show methods dialog when you press cancel versus when you return an empty string?
Okay, who knows how you can tell that the user pressed cancel? on a text, on an input dialog, yeah. Right, it returns a null string. So you can test for null, yeah.
So what's the difference then if you just press enter when you don't have anything?
Okay, if you press enter, you get back the empty string, different beast. Empty string is a string with no characters in it. It's a string of length 0. Null, it's just null. It's a value you can use in place of any object. It just means no object here. So two different things. Any other questions? Okay. Now, in the lab yesterday, you experimented, tried to write some missing pieces of code for a few methods that I specified. And, I talked to the TAs about it, and they said that the students that that came into the class with some programming experience did pretty well, but that most other people struggled quite a bit. Perhaps didn't finish it by the end. So I want to go over this as a way of trying to hammer home how you can write programs that make use of collection classes. So this is one of the examples, one piece of code from the lab. So what we did was we created an empty set called all words, and then input is wherever we're reading from. So let's just think Pride and Prejudice. So we read a word at a time, convert to lowercase, and then add it to the set. So this loop returns a set consisting of all the words in the input. Right? I think that's pretty easy to understand. I want to see, I'm willing to be shown wrong. Of course, having said that it's easy to understand, that immediately discourages questions, because no one wants to be the person that didn't understand the thing that was easy to understand. So I'm sorry I said it. I think that's really hard. Does anyone have any questions about it? Okay. So, the one fundamental operation on sets is add. You want to put something in a set, you call the add method. Yeah?
I remember during the lab that I wasn't able to add something directly to an array inside a get statement, because add also returns a Boolean value.
Well, okay, so he's asking about using an add inside of a what statement?
Well, I had a put statement that updated the value of something inside a map, and I wasn't able to use the add inside that because add also returned a Boolean value.
Okay, I'm not quite understand. I need to look at that to tell you. Maybe Stefan knows.
What he did was do a put, and then you have to put the key in the value, and then while he's putting in the value, he tried to do a dot add there,
Oh, okay.
and it didn't work.
Okay.
Instead of,
We can talk about that later.
Oh.
Yeah. Okay, but what I want to do is help you visualize what's going on. So we're creating a set. And the first thing we do, the first line of code, we create an empty set called all words. So there's our set, sort of this nebulous cloud. It's empty, there's nothing in it. Now suppose we're scanning, this is a test is, I think was the string I was using as an example. After the first time through the loop, what does the set look like? What does all words look like? What does it contain?
This is a test.
No, after one time through the loop, sort of. Right. So this gets put in there, and then what happens? Is shows up, and then shows up, and test shows up. What about the next time through the loop?
Nothing.
Right, you try to insert but it's already in there, so the set doesn't change. And then the last time through the loop, you try to put in is, and it's already there as well. So that's what's happening as the method runs. It's building a set like that. And of course, internally, it's represented in a very different way than like we're picturing there. This is an abstraction. But that sort of gets to the gist of things. All right, so that's our first example. I'm going to try to visualize all of the methods that you worked with. So that shows you building a set. Now, if add is a fundamental operation on sets, what other fundamental operations are there? else would you want to do to a set? You might want to remove a value from a set. You can do that. What else?
Get.
Well, there's no get. There's no get. There's something like it. What's the question you might want to ask about an element? Yeah?
Check and see if something is in the set.
Right, right. That's contains. So there's a method to check whether the set contains something. That's basically why you have sets. You have sets so you can check later to see if they contain something. Okay? So add, remove, and contains. Hope I've got those named right. But that's what they do, if that's not their exact name. Okay? Now, here's another one we looked at. Let's see what's different. This one is creating a tree map that maps from strings to integers. Okay? So the key is a string, which will be a word. And the integer is an integer. And the idea is that every word, after this runs, it will create a map that maps every word that occurs in the input to the number of times it occurs. So if we feed that through there, if we process this is a test is, and we ask word counts to get the value of this, what would it return? 1. So when we say word counts dot get of the string this is going to return 1 because this occurs once in the string, so this is going to be mapped to 1. If we ask to get the value of is, it'll return 2 because that occurs twice. What about if we ask it to get the value of Joe? Yeah?
Say that it doesn't exist.
Well, he says it'll say it doesn't exist. How does it say that? It returns null. So if you ask it to get the value of Joe, it would return null. Now, let's see how this gets built up. You notice every time through the loop, we grab a word out. And if the word is not in there, so there I'm saying, I'm looking up the word. Think of it as looking up something in a dictionary. Some languages call these things dictionaries instead of maps. So I get the value of the word. If it's null, what does that mean? We just said it's not in there. We haven't gotten around to putting that word in the dictionary yet. So what we do is if it's not there already, we put it in there with a value of 1 because we've just seen the first occurrence of the word. If we'd seen it before, it'd already be in there. Otherwise, what do? What's going on right here? That's bad. Why does it keep doing that? What's going on after the comma there? Yeah?
It's accessing the value.
Okay, so it's getting the current value of the word, which is the number of times it had occurred up to this point. Then what's it do?
It adds 1 to that.
It adds 1 to it, because now if it had been seen 3 times before, now it's been seen 4, and then we put it back into the map. So if is mapped to 1 before, now is will map to 2. So notice put will do one of two things. Put will put a completely new thing in, or it'll replace something that's already in there. So the put in the else part here is going to replace whatever value the word had in the first place with something that's 1 more. Okay? So when this is all done, well, let's see what it'll look like. So first thing we do, the first line of code is to create an empty map. So I'm using the same cloud to see a map. And then what's going to happen the first time through that loop when we see this? Yeah?
Go through the if statement and it's going to put this and 1 next to it.
Okay. So it's going to, the if statement will work, it won't get to the else, and it will map this to 1. So that's what happens. This gets mapped to 1, so that's my notation for that. It's added a new key, this, a new value 1. What happens the next time through the loop? Someone else tell me. Yeah?
Is gets mapped to 1.
Right, we'll do the is, and it'll get mapped to 1. Okay? What happens next? Go ahead.
We got A mapped to 1.
Okay, so that gets mapped to 1, and then we know that test gets mapped to 1. Now, what happens the 5th time through the loop? Go ahead.
When you pass the word, then you reach the else statement.
Okay, that gets us to the else statement, because when we look up the word in the if, we'll find out that we don't get null back. So what we do is we go look it up to get it, sort of look it up again, and we get the integer back. That'll be a 1. So when we say word counts.get a word, we'll get back 1. Then we add 1 to that and store it back. So what will change about my picture?
2.
Right. The thing A goes to will be 2. And then the last time through the loop, the same thing happens with is. So what you've done as you've gone through the loop is build up that data structure in memory. Now we're not doing anything with the data structure except print it out. But you can imagine writing a completely different method that took these things apart. Suppose you had this, and someone said, how many times does the word Elizabeth occur? How would you compute that? If you had this data structure already built, how would you answer the question, how many times does the word Elizabeth occur in Pride and Prejudice? Yeah.
You do word counts.get Elizabeth.
Yeah, you do word counts are cloud.get of Elizabeth. And we either get back null if Elizabeth didn't occur in the book, but it does. So what you get back is the number of times it occurred. Okay, so that's that. Any questions about how that works? Okay, I guarantee you your next assignment will involve plenty of maps and sets and arrays, so don't think this is going to blow over. Yeah?
If we have a value, is there any way of finding the key that's assigned to it?
So he's asking, is there a way to go backwards? Given a value, can you find a key? There's no built-in way to do it. How could you do it in practice? Suppose you had to do it. Suppose someone gave you a phone number and a phone book, gave you a phone book, and they gave you a phone number, and they said, use this phone book to find out whose number this is. How could you do it?
You could iterate through the keys and then compare the values.
Right, I have to basically search through the phone book looking for that phone number. It'd be very tedious. What you can do in a program is you can get, we'll see an example of this, you can ask the map for a set containing all the keys, and then you can iterate through the keys, look each key up in turn until you've found the phone number. So yeah, it's not an efficient operation. All right. Okay, so let's see. We just did this map here. Now the last thing we did was turn the mapping around. So this one maps this to 1 and test to 1 and is to 2 and to 2. We wrote code that turned it around so that each count was mapped to the set of words that occur that many times. Why a set? Okay? On this page here, this slide here, we created a tree map that maps strings to integers. On this one, we're creating a tree map that maps integers to sets of strings. Where did the set come from? Yeah?
You can have different words that occur the same number of times, so you want to be able to include all of them.
Okay. So what she said was, you can, like, take the number 3. There can be any number of words that occur 3 times. There may be none, there may be 7, there may be 100. Now, in an original problem, a word, it's not like a word occurs 3 times or 5 times or 7 times. It occurs some number of times. When we flip it around, it's just a different problem. So we need to map every count to the set of all words that has that count. And so up there I put up the 2 things we've already computed. Word counts. Well, the one thing we've already computed, word counts. When we flip it around, when we reverse it, what will the keys be in the new map? If we ask for all the keys in the new map, what will they be? Yep.
Integer the 1, 2, 3, 4.
Well, in general, it could be any integers could be the key, but what specific integers will be the keys in the new data structure? Yeah?
Any value that appears in word counts.
Any value that a word is mapped to in word counts. Well, what values are words mapped to? 1 and 2. So when we run this code, we'll end up with a cloud that maps 1 to something and maps 2 to something. What will 1 be mapped to? Yeah?
It will be mapped to a string of arrays containing this and test.
Okay, it'll be mapped
Array
to,
of string, sorry.
be mapped to a set containing this and test. And 2 will be mapped to a set containing is and of. And we're just, why do this? Why reverse the map? Seems like a big pain. You end up with complicated data structure, mapping integers to sets. Yeah?
Makes it a bit easier to look for like certain information, like you want to know how many times a specific word occurs.
Right, so if the question you want to ask is, which word occurs the most times, then this new formulation works nicely because you can just look for the largest key and it'll tell you how many words, what word or words occur that many times. So it just makes it easier to ask certain questions. But the code, though, is a little more complicated. I think this is the code from class. So first thing we do is repeat that empty map. But let's break down how we declared it. We said the key is an integer. The value is a tree set of strings. All right? So when we're all done, what will be showing up in that cloud? Well, back here, we created a map. And the cloud had this, which is the key, followed by a colon, followed by a number. Test, colon, number. What do you suppose this will look like? Not that. What do you suppose that will look like once we've added stuff to it? All right, you can answer. Go ahead.
1 colon this test.
Okay, so there'll be 1 colon, and then there'll be a set. What will the set look like?
Curly brackets.
You think it'll be curly brackets, but I haven't drawn a set like that today. What would it look like? It'll be a cloud. That's how I'm drawing sets today. So there'll be a cloud containing this and that, this and test. There was a hand going up here. All right? Let's see how it works. So first time through the loop, we, okay, I'm getting ahead of myself. Look at the for loop right there. So we're asking, we want to look at all strings that occur in that set, in the set word counts.keyset. So keyset's a useful method on maps. What it gives you back is a set that contains all the keys. Because we want to do something to every key here. What will that set contain? You don't have to think too hard to answer it because it's up there. There it is, that second little cloud. What does it contain? The 4 keys, the 4 words that are keys in the original. And so you can see up there the keys are this, test, is, and And the key set is this, test, is, and So we get that set, and then we use this special kind of for to iterate through. Now, as an aside, it would be very difficult to iterate through a set if it weren't for this type of for loop. Because there's no method to index into a set. The way you systematically work your way through a set is with this type of for loop. Yeah?
So yesterday we wrote, so word counts, we made that in a different method, but we called it in like the next one. Is that something specific to tree maps that you can call them like in a different method, or?
No, it was being anything that you were using in the method was being passed in as a parameter.
Oh, okay.
So what happened was yesterday, your next to last method computed something, a map, and returned it. Mm-hmm. And that map was passed to the next method.
Oh, okay.
So it wasn't any kind of magic. It was just being passed in as a parameter.
Right.
All right, so we're going to walk through everything there. And each time through the loop, we'll do it to 1. So let's just take it in alphabetical order. What will happen when we ask for the value of the word from word counts? What will we get back? Gotta say it louder. 2. Right. We look up there, we get back 2. So count will be 2. Then we're going to go into count map, which is this thing over here. So that's word counts up there. This is count map is the thing we're creating. And we're going to look up 2. What are we going to get back?
No.
Null. There's just nothing in it yet. So we get back null. And so what we do is we put 2 into the map with an empty set as its value. I don't know if I've got that. Yeah. So that statement inside the if creates that thing up there into the map. It puts 2 and has it mapped to the empty set, which is a cloud with nothing in it. Then we fall through the if. What does that last statement do?
It tracks the set to the cloud.
Right, it goes to count map and it asks, it gets out the value of 2. Well, what is the value of 2?
Is
No, it's not null. Look at the picture. What is the how would you describe the value of 2 up there? Black cloud? An empty set, yeah.
B is and A right after it.
No. That's what, let's see, that's called count map. That's what count map looks like right now. And we say count map.get of 2. What do we get back?
Empty set.
That empty set that's drawn as a black cloud. So we've got that black cloud in our hands, and we call a method on it and ask it to add a word to itself. So we're basically obtain the black cloud, and then we change it by adding a word to it. So how does a black cloud look after we've done that add?
A will be an element in it.
No. That word shows up in it. Now, at this point, you got to check your assumptions. Because what I did was I went over here with the get method. I obtained that black cloud, came over here, and I put the word A into it. How did that change the one over there? It seems like if I go over here to my map and I get this black cloud and wrench it out of there, which I'm doing with the get, and then I add a word to this. Yeah, now I've got a black cloud with a word in it. What about that black cloud over there? Yeah. They're the same. It turns out whenever you obtain an object, you don't actually, what you get is a reference to it, a pointer to it, an address in memory. And 2 different parts of the code can have references to the same object. So I don't go wrench the black cloud out or copy the black cloud and bring it over here. I just say, okay, I've got that black cloud over there. Put 2 in yourself. And it changes itself. Yeah?
Did you specify to put A in there, or?
Yeah, what line of code here put the A in there? Yeah?
The last one?
Right, the dot add here.
Well, I mean, instead of A or is or test, instead of those
Oh,
words.
well, it just depends. We're iterating through all the words in the key set. And I just said, let's do it alphabetically just to be concrete. It's happening in some order.
Okay.
Okay? Now, what's going to happen the next time through the loop? This time we'll get is, which is next. Okay? Yeah?
We put is in the same set as another element.
Okay, so we'll find out that, we'll look up is over here. We found out is occurs 2 times up there in word counts. Then we're going to look up is, we're going to look up 2, the count. And what will we get back? We'll get null back? No. We'll get back that black cloud. And so then we skip the if and we fall down to this last statement, which gets the black cloud out by looking up 2, and then it adds this, or is rather, to it, and it looks like that. Now the black cloud contains 2 things. Now, next time through the loop, we've got test, let's say. What's going to happen? Test. What's going to happen? Yeah?
The if statement will execute. So to create a new cloud with 1 as the key,
Okay?
And then it'll, once it exits if statement, it'll add this to the class.
Okay. So we're going to ask how many times we look up this. No, be test with it. Stop there. We look up test. We find out it occurs one time. We look up 1 over here, and we find it's not there. And so we map 1 to the empty set. Then we go to the very last kind of code. It gets that empty set out and adds test to it. And then the last time through the loop, no, I don't know why I did that. What's wrong about that? It should have added this back to the same cloud as test. I shouldn't have 2 things that one is mapped to. So I'll fix that later. I don't know how they got past my proofreading there. Okay, so that's a mistake. We should have test and this both in that black cloud. Yeah?
Can we use contain? Like count mac.contain count is false?
I think there's a method. I don't think contains. I think it's contains key.
Oh,
Yeah.
oh,
But there is a method. You could do it differently. Rather than calling get, you could call contains key. Yeah.
Can you explain again why the loop repeats twice on the 2 or 2?
The loop doesn't repeat twice for 2.
How does it store 2 values there?
Well, we go through for so going back here. Okay, first time through the loop, we've got It occurs 2 times. So we have to create the empty set and add to it. The next time through, we're working on we found out it occurs 2 times. We do the get and find out that there's already a set associated with 2. And so we skip to the last line here. We get that set, that black cloud, and add is to it. So the first time through the loop, we end up changing the same black cloud both times. We create it and change it twice. And the same thing should have happened here, but I messed up, so that's wrong. Okay, now, this picture here is kind of misleading, besides the fact that it's just plain wrong. And what's misleading is it looks like that the black clouds are physically contained inside the white clouds. That's actually that's closer to the truth. The white cloud contains references to the black clouds. And because of this, the way objects work, well, let me say, how else could we fix this up? Those numbers there, the 2 and the 1, aren't ints, they're actually integer objects. Are they contained by the black cloud? What would be the right way to draw them if I wanted to? Yeah? There'd just be, really, I would replace the 2 with an arrow out to some place in memory that has a 2. So objects are always stored indirectly via a reference. And that means that you can have, let's say right here, you say count map, the variable count map does not contain the white cloud. It contains a reference to the white cloud. And you can have a variable set that refer to that black cloud. So you can have 2 different things referring to the same object. So you notice we have a variable set that happens to be referring to that black cloud. What happens if we change set by doing a put operation on it? Will that change the black cloud that's referenced by the map? Absolutely. It's the same black cloud. The white cloud is referring to the black cloud, set is referring to the black cloud. Anything that set does to that object is going to be reflected in the white cloud as well, because it's the same one. What about those strings? Strings are objects. Should they be drawn inside the black cloud?
No.
No.
Why? They're primitive type.
All objects are stored by reference, via a reference. So really, I should have like this, unless those are both a little bit wrong, is I don't think I have a slide. It really ought to look something like that. I mean, we could keep going, and eventually the diagram becomes useless. Why hasn't this come up before? We've been using strings since day one. Why haven't we had to worry about the fact that strings aren't copied around, they're just referred to indirectly? Yeah?
We sort of have, that's why we can't do the equals.
Okay. That's why double equals doesn't work. What double equals works to say, when you do double equals, you have a variable that contains a reference to a string, another variable that contains a reference to a string, you ask if they're double equal. It's asking, are the references the same? Whereas dot equals will say, do the strings contain the same characters? Yeah?
Well, I think it's not obvious because you can define a string in much the same way you can define a string.
Okay, he says he's observing that you can define a string in the same way you define a primitive. In other words, there are literals for it. The other thing, though, is, what really makes the difference is there are no methods on strings that change the strings. The fact that strings are referenced indirectly isn't important because, if I have a reference to a string here and a reference to a string there, there's no way I can go and change this string. I can't go in and change index 0 to something else. I can make new strings that are similar to the old strings, but I can't modify an existing string. And so this issue didn't come up. But it comes up with lists and sets and maps because they can be modified. The word is mutable. Lists and sets and maps are mutable. Strings are immutable. And it just gets a little more confusing dealing with mutable objects. Okay, so I'm saying strings aren't mutable, so it's kind of overkill to emphasize that. So in this picture, I'm sort of emphasizing what I want to emphasize, which is that I want to emphasize objects are stored indirectly by reference. The complete truth, it would just be a bunch of ones and zeros in memory, and that would be completely unilluminating. So when you draw pictures, it just depends what picture what you're trying to emphasize. Okay? All right, let's take a break and we'll look at some similar problems. Okay, now let's suppose I want to know all the words that follow immediately after Elizabeth in Pride and Prejudice. Okay, so this is going to be similar to stuff you did in lab. We're going to just work through the examples again. And the question, which wasn't supposed to be revealed, was what type of object do I need to hold the result? So why does it make sense that I use a set of strings? Yep.
If you need to know, like, all the strings, as far as, like, all the words that pop up.
Right. I need to have a collection, first of all. And a set's a collection. But why not a list? Yeah.
Well, for one, it doesn't particularly matter what order they occur in.
Okay. So you don't care about the order.
And you also don't want any duplicates.
And we don't want duplicates. So we can either create a list and then go around eliminating the duplicates from it, or we can just create a set and let the set deal with it. That's why we choose that. Now you notice it says set up there as opposed to hash set or tree set. In a real program, you decide which one to use. But they have the same methods, the same properties. It's just that they implemented differently, and the different operations have different efficiencies. And we're not really concerned about that. Just for variety today, I'll use hash set in all the examples. Hash sets are typically, the difference is hash sets are faster than tree sets. But when you iterate through a tree set, things come out in less cryptographic order. Whereas a hash set, they sort of come out scrambled. So if you don't care about what the order in which you get things when you iterate through a key set of a map, use a hash set. It's faster. Okay, so that's what we want to do. I want to know all the words that follow immediately after Elizabeth. So let's go. Make sure I'm in the right place. Lecture problems is what I want. Okay, so here I've got this method up here, which opens the book, creates a scanner from it, sets the delimiter so we ignore punctuation, and then calls problem 1 with the scanner, and then prints out the result. So we'll use that same main method for everything. But here's problem 1 on today's slide, one we just talked about. I want to get back the set of all words that follows Elizabeth. So I've written part of the code for you here. Let's see what I've done. I create an empty hash set called words to hold the result. When I'm all done, I return words. And then I have an if that reads the first word from the scanner. So assuming, what that says is assuming there's at least one word in the scanner, read it. That's our first word. Then I enter a loop which reads, it repeatedly reads the next word into a variable called word2. So the idea is that at any given point in time, word2 will be the word most recently read from the scanner. Word 1 will be the one that was read right before it. Got a question?
Why would you use a hash set over like an array list that contains strings?
Well, he's asking why I use a hash set over an array list. Because we don't want duplicates. All right, so my question for you is, what goes here, right where that comment is? So I've taken care of, I've got the loop set up now so that the idea is that word 1 will be word 2 will be the most recently read word, word 1 will be the one before it, and we're trying to add to the set every word that follows Elizabeth. So take a couple minutes, talk to people around you, think about it. You'll understand my solution a lot better if you at least think about how you would do this. Try to figure it out.
I'm going to just declare like a variable called Elizabeth, a string variable. Word 2 that equals whatever. Or I didn't even need to declare it. You do another if. It's a statement. If word 2 dot all lowercase.
Questions be worded.
Then,
You have a question.
then
Then
you take that to word 2. Or no, you have to
word 2 would be has next to jump straight in line.
Word 1 is the.
Wait, are you doing the words after?
So if there is one,
the word after
then we check
the word
This
take
method
that
goes
one
return
to
set
scale.
containing every word
Oh,
that
okay.
occurs
Oh, so if word 1 equals dot equals Elizabeth, then word 2 goes.
Yeah, but we can't find the zero.
Because scan next.
Oh yeah. So if word 1 is equal to Elizabeth, then we have word 2 is.
Yeah.
What is it? The hash.
Yeah, do words dot add and then
Word 2. If word 1 is equal to
word
dot equals
words dot add and then. So do you need another?
what?
Another if. Yeah, you need to put another if.
Does word 1 never update? Oh, we need don't we need to update word 1? I don't know.
Because once you add word 2, it'll go back to.
It'll still be inside the while loop. So word 1 will never change unless we update it, right? And then after that we have to word 1 full stop.
Okay, let's see what you've got. Now, there are about 5 or 6 students that we'll call the usual suspects. And I appreciate the usual suspects because they're always willing to answer questions. But it's nice sometimes to hear from other people. So, if you don't consider yourself a usual suspect. Yes?
All right, so just to make sure I'm following right, we're trying to see what words follow Elizabeth, right?
Right, we want all the words that follow Elizabeth.
Okay, so we'd actually have to see if when a word that comes in is actually Elizabeth. Right?
Okay, and we've got 2 words here. We've got the most recent word and the word that came before it. So which word do we want to be Elizabeth?
The word that came before it.
Right, word 1.
Yes.
All right, so how can we find out whether word 1 is Elizabeth? Okay, so we'll say if word 1 equals everything, we're doing everything in lowercase here. Okay, so we can test to see if word 1 equals Elizabeth. Okay, someone else tell me, what if it does? What do I do? Yeah? Okay, so what we do is we add word 2 to the set. We don't add word 1 because word 1 was Elizabeth. We want to know the word that follows it. All right, now, suppose we now run our program. What do we have?
Set with one.
Do we have a correct program? What do I need to add to my program? Yeah.
Just set word 1 forward.
Okay. So the problem is, if we write the loop as we have it here, word 1 will never change. Right? We're in this little loop right here. Word 1 will always and forever be the first word in the book. And so, since Elizabeth is not the first word in the book, we would never add anything to our list. In fact, if I run this, at this point, it will come up with the empty set you see right there. Okay? So what he suggested was, after we have checked word 1, we do this. Okay? So someone else, explain the logic of that. Why does it make sense? Yeah?
You've now set the first word to be what that second word was, so that word 2 is now the one after that.
Okay. So we always want word 1 to be the word 2 to be the most recently read thing, and word 1 to be the one before it. So what we do is, after we're done with word 2, it becomes the new word 1, and we read a new word 2. So that way we're always moving through with these 2 consecutive words. Now I told you at one point, we studied different types of loops, accumulation loops, and searching loops, optimization loops, counting loops, or enumeration loops. Did you ever see anything like that? Any loop that had 2 variables and did this sort of thing at the end? Yeah?
Was it the one where you had like a new champion every single time something was bigger than the other?
Well, okay, so you're thinking of optimization loops where we were updating an optimization variable. But this isn't quite the same thing. Yeah? Say what?
Is it recursion?
This isn't recursion either. Yeah?
I think it's similar to a enumeration loop. You're basically just moving a step forward.
Yeah, he's saying it's similar to an enumeration loop. But here's the bottom line. This doesn't fit into any pattern that we studied. And I told you at the time when we studied those common patterns that it might work 90% of the time. 90% of your loops might fall into common patterns. But every now and then there's an outlier. And so some of you may be looking at this thinking, how in the world could anyone conceive of writing a loop that works this way? And yet, when I wrote this code this morning, I didn't think twice, just because I've done this so many times. I was familiar with the pattern. And now you've seen it, and maybe you see it a few more times, it would start to come natural to you as well. It's just a trick. Essentially, as you're learning the program, you're doing lots of little inventions. And if you'd been the first person to ever write programs, you'd be the first person to make these inventions. But that's the process of learning. You sort of discover neat little tricks to let you do things. So now if we run the code, then there we get our set. These are all the words that occur after Elizabeth. Even Lizzie occurs after Elizabeth somehow. Okay? So any questions about that? The code we added was pretty compact. We just said, okay, if the previous word was Elizabeth, add the current word to the set, and then, no matter what happens, our current word becomes the previous word now, and then the loop repeats and we pick a new, we'll come up here and pick a new current word. So maybe I should have called it current word and previous word. That would have been a better choice. Okay. Well, let's look at another example. Problem 2. Well, I really messed up. Now I want to know, for each word that follows immediately after Elizabeth, I want to know how many times it does so. So I don't just want to know these are the words that follow it. I want to know, okay, Lizzie follows it once. But Bennett follows it 10 times, whatever. And again, it was supposed to be the big reveal. It's being exposed prematurely here. Why does that work? Map, something that maps from strings to integers. Yeah?
You can take each word that occurs after Elizabeth and then as a key and as a value assigned to it as an integer, you can know how many times it occurs.
Okay. So we said, the words that come after Elizabeth will be, so every word that appeared in that set we just computed will be a key in a map. And the value for that key will be the number of times that word occurs. So we would map Lizzie to 1 maybe, and we'd map Bennett to 80, whatever, and so on. Okay. That's very similar to something from the lab. So let's look at, let me see if there are any questions about the problem here. So we're expecting back a map as opposed to a set in this case, because we want to count for each word. So the words are the keys, the number of times they occur are the values. Yeah?
Would the strings be, would it be possible to make it so that the map, the set we just made, is put into the strings so that we already have the words that pop up afterwards and just
I'm not following that exactly. So, we'll talk about it later. Okay, so let's go look and see what code I've written and what code you need to write. So here's problem 2. So, once again, I'm using the same trick from before. I'm reading word 1 at the beginning. Each time through the loop I read word 2. After I'm done, word 1 becomes the old word 2, and we read a new word 2. So that's the same basic structure as before. And then if word 1 is Elizabeth, we want to do something. The question is, what do we do? So again, take a couple minutes, talk to people around you. What goes inside that loop? When we find word 1 is Elizabeth, we know word 2 follows it. What do we do with word 2? And what do we do with word 1? How do we modify word counts? Bottom line. Word counts is the map up there.
Word counts like get word 2.
Oh, yeah, check if it's number and then we have to do a put.
Yeah, put that and 1.
Yeah.
It's not all it is. You just put that and get the value out.
And do the else.
Yeah, get the value out.
Yeah, and then we finish it with the word 1.
Oh, yeah. That's already good.
Yeah. Okay. Word count.
I was wondering if you could use the same as like since it turned to set.
Yeah. Looks like it is while instead of storing it to the set, we just it's still kind of basically the same, except for like this little bit here.
Okay. So in English, what do we want to do? Yeah?
If word 2 isn't in the hash map, we want to add it to it, and if it is, we want to up its value by 1.
Okay, so if word 1 is not in, okay, so word 1 is not in block type. So if word 1 is Elizabeth, we care about word 2. And she said if word 2 is not already in the map, we need to add it to the map with a value of 1. Otherwise, we do an update. So it's similar to what we looked at before. How can we tell whether word 2 is in the map already? Yeah?
So we do word 2, word count dot get word 2.
We could do the get. Let's try it a different way this time. We'll use the contain. Someone asked about this.
Oh.
So there's a contains key that'll tell you whether or not something belongs. So we'll do contains key of word 2.
Oh, so
And if that's not true, if word counts does not contain word 2, that's one thing we do. So what do we have to do if word 2 isn't in the map at all?
word counts or put.
We better put it in there. So we'll say word2.put. What should be the value?
Word counts.
Word counts.put. The key is what?
Word 2.
Word 2, and the value is?
1.
Yeah, 1. Otherwise, what do? Do something similar. We got to update count 2. We got to update word 2.
Word count. Yeah.
So we need to go and get the current value. And add 1 to it and put that back in. So we just store a number back that's 1 bigger than what was in there before. So now if we run this, we get the same thing because I didn't change the main method. So we want to call problem 2. And we get that kind of match. Silently occurs 2, half occurs 1, thought occurs 3 times, and so on. Okay. Okay. Now there are a couple others like this. I'm going to leave them for now because there's one more example I want to talk to. Maybe it'll show up on the assignment or something. Okay. So just to show you what we're skipping over for right now, there's a problem where I want to do what we just did, but for all words, W. For every word, what words follow it. There we get something that maps a string to the set of strings. And then finally, for every word, I want to know all the words that follow immediately after W and how many times they do so. So that is something that maps a word. For every word, there's a map that says how many times other words occur after it. Okay? So you look forward to that. But this is an example I want to finish up today. It's the table sum problem. So imagine you have a table, and the table can have any number of columns, and the table can have any number of rows. And the top row is special. The top row are the headings, the headers for the column. So you can see I have a header called name, one called city, one called age, one called salary. So name contains people's names, city contains names of cities, age contains numbers, salary contains numbers. And the problem is this. You are given a condition header. So you're given one of the headers, and that's called the condition header. So I've made the condition header yellow right there. You're given a value header. That's what I got pink here. And you're given a condition value, which is a value that shows up in the column, the yellow column, the condition header column. And then what you're supposed to do, let me step through this and show you what you're supposed to do. So suppose you're told the condition header is city, the yellow thing. The value header is salary, the pink thing. And you're told the condition value is SLC. So what that tells you you're supposed to do is find every row that has SLC in the city column. So I've highlighted the SLCs in yellow. Then you're supposed to go over into the pink column and find all the numbers that are in the same column as SLCs. So which numbers will turn pink when I hit my space bar next? Which of those numbers are in the same row as SLCs?
75,000, 80,000.
Yeah, 7,500, the 75,000, the 80,000, and the 0. So essentially, what we've highlighted are the salaries of people that live in Salt Lake City. Then you just add up an average. So that is, you add those up and average them. So we want a method that can do that sort of thing. You give it the yellow header, you give it the pink header, you give it a value in the yellow column, and it averages everything else. So what's another question we could ask? I've just shown you how to ask the average salary of someone in Salt Lake City. What's another kind of question we could ask using this method I want us to design?
How many people live in one city?
Well, how many people live in one city? That will, oh, yeah, okay. That's certainly a question, but it's not in the same format here that we need. Yeah?
What's the average salary of people between the ages of 18 and 50?
Okay, she said, what's the average salary of people between a certain range of ages? Our method isn't even good to do that. We could ask, what's the average age of all 25-year-olds? thing we could ask is, we could ask, what's the average salary of, this is stupid, everyone named Mary? Or we could ask, what's the average age of everyone from Salt Lake City? That's probably the most reasonable thing we could ask. Okay? So we want a method that takes in this table as a parameter. It takes in the condition header, the yellow header. It takes in the value header, which is the pink header. And it takes in a particular value in the yellow column, and then computes the average of the corresponding values in the pink column. So that's the problem. And we'll pass in the table as in the form of a scanner. And the idea is the scanner will contain all those entries separated by tabs and new lines. So the scanner would contain name, tab, city tab, age tab, salary, new line. And then John tab, Salt Lake City tab, 25 tab, 75,000 new line, and so on. So let's just think for a second, what would it take to implement this method? How would you, if I were to assign this, how would you approach it? It's more involved than any method that I've assigned in the past, because there's a lot to do. So what's your idea?
So first, for the scanner, we could use the next line.
Okay, so yeah, we're going to take it apart with next line. So we can grab one line at a time out of the scanner.
So using a count, I guess, we can, for the very first line, we can make a new map and have each of the values in the first line of the scanner be assigned to the key of a map.
So he's talking about using a map. Clearly, the first line is important because that contains all the headers. So what do we need to know? If someone says, here's the headers and the condition header is city, what do we need to figure out in order to make progress? Yeah?
What column number city represents?
Yeah, what column is city in? So if the condition header is city, we would like to find out, okay, that's column 1 if we're doing zero-based indexing. And then we'd like to be able to figure out that salary is in column 3. So are those two different problems, or do they sound like the same problem? They're pretty similar problems. So maybe what we need is a method that takes a row from the table, the first row of the table, and a header, and tells you what column it appears in. Once you know what columns we care about, we can throw the first row away. So it sounds like we need a method to do that. Okay, now, how are we going to deal with individual rows? We need to be able to index into them. So we've got a row, it's just a string. If we read one row at a time from the scanner, we're getting strings. But we need to be able to index into them to do the operations we need to do. How can we handle that? Yeah?
You can store each token as like the number in an array. So
Okay, we could create an array, for example, because array will work this time because we know how many columns there are. So we could create an array of strings to hold each row. Okay? So taking these observations, this is sort of thought process you go through when you design the program. You're thinking, one problem is figuring out what index a header is in. So you can create a method to do that. Another problem is for each row I want to put it into an array so I can do indexing. So we need to have a method to do that. So we've done our wishful thinking. We think, if I could figure out what column headers are in, and if I could turn rows into arrays, then I could write a loop to do this. So let's look at my solution anyway. This is my table sum method here, table sum class rather. And there's a comment that just says what I said. There are some exceptions you throw. So let's see what I did. I read the first line, that's a header row, so I'm just using a next line operation on scanners. And then I realized I needed a method that could tell me which column different headers occurred in. So I say, okay, what column of the header row does the condition header appear in? The condition header is a parameter up here. And in which column of the header row does the value header occur? And I just save those right here. So now I know which column is which. Then I just write a loop. And in the loop, I'm counting how many, I'm adding things up and keeping track of how many things I've added so I can compute an average at the end. So while there's a line in the table, I read it, And then what's going on here? I've read a line from the column. I've read a line from the input, from the scanner. What am I doing with it? Yeah, there's a neat line method called split. And it takes as a parameter a delimiter. In this case, I'm using tab. And essentially, it splits that line up into an array, and it splits it on the tab, where the tabs are.
It's a string method, not a line method.
What did I say? A line method. It's a string method. So we don't have to, we wished for a method to find column indexes. There wasn't one, so we had to implement it down below. We wished for a way to split our lines up into arrays of strings. Lo and behold, there's a way to do it. Sometimes you wish for things that exist. Sometimes you wish for things that you have to create. And now we can just say, for each line, we can say if we look into the, so the array is called columns. If the condition column contains the condition value, then we increment the count and we add in the value from the value column. Otherwise, we don't. When we're all done, we just compute the sum. So the key thing I'm trying to get across to you here is, sometimes you've got a method, it's just too big to do all by itself. So design involves figuring out what helper methods will make your life easier. Sometimes the method already exists, sometimes it doesn't. And then here's my find column index method. It splits the header row into an array, and it just searches the array looking for the header. So it's just a search loop. So it just iterates through the array, and when it finds the header, it returns the index. If it doesn't find it, it throws an illegal argument exception. So your next assignment will involve some stuff with maps and collection classes. But it'll also involve methods that are a little bit bigger, for which you're going to need to break things down. So that gives you practice taking a slightly larger problem and decomposing it into simpler problems. And I just want to emphasize that the exam that's coming up after fall break covers through today and through problem set 6. So we're going to start new stuff next week. That won't be on the exam.
I wanted to